I posted a video on this question before, but there's an easier way to solve this one. Now, if we look here, we get 60 degrees here. That makes this 120 degrees here. The smaller triangle, the ABD, you got 30, you got 120, that's 150. We got 30 left over, so this is actually 30 degrees here. We have two angles the same, like here in the triangle. It's an isosceles triangle. So if AD is 80, BD is also 80. Okay, so now the other triangle, BDC, is a 30, 60, 90 triangle. Got 60 and 90, so 30 is left over. So now we can just use a ratio of a 30, 60, 90. Remember that is 2x for the hypotenuse, x opposite the 30, and x square root of 3 opposite the 60. So here, if this is 80, this can be 40, this be 40 square root of 3. Okay, so no algebra needed for that one. All right, let's take a look at another one. This one says, in the figure below, triangle ABC is a right triangle, where point D lies on AC, and the measures of angle BAC and BDC are given. The length of AD is 15 feet. What's the approximate length in feet of BC? Okay, so again, when you see 30s and 45s in a right triangle, you should think of the special right triangles. There's several ways to solve this one, so I'll go through the various methods. Okay, we see we have 45 here. This is also 45 degrees. So this BDC is a 45, 45, 90 degree triangle. We can relate the legs as x, so both of these are x. Okay, we can use algebra to solve this. We can say tangent of 30 equals opposite over adjacent, so x over 15 plus x. Okay, multiply both sides by 15 plus x. We can distribute the tangent of 30. I'm going to make the x's the same side. Then factor out the x. And divide both sides by 1 minus tangent of 30. And use your calculator for that. 15 times the tangent of 30 minus the quantity 1 minus tangent of 30. And you get about 20.5. So that's the algebraic way to solve it. Let's look at another method on how to solve it. Now another way to do this is look at this as a 30, 60, 90 degree triangle. And we got 30 here, we have 90 here. That means this angle is 60 degrees. So we can say BC, this is opposite the 30 degree angle, so that can be x. AC would be x square root of 3. So we know AC divided by BC would equal x square root of 3 divided by x, which reduces down to square root of 3, and in decimal that's about 1.73. Now if I call DC W, that BDC is still the 45, 45, so BC is also W. Okay, so we set up this ratio. AC is 15 plus W, and BC is W. We just said that should equal about 1.73. So you could just plug in the answer choices for W. and then see which one gives you 1.73. And once you get to 20.5, you do 15 plus 20.5 over 20.5, and that comes out to about 1.73. Okay, so that's using answer choices. You could just solve for W here instead. So if I did that, I would multiply both sides by W. 15 plus W equal 1.73 W. Then I'll subtract 1 W from both sides, give me 15 equals 0.73 W. Then divide both sides by 0.73. And I'll give you about the 20.5 there. So these two problems dealt with the 30, 60, 90 triangles, 45, 45, 90. So make sure you know those ratios. So again, for 30, 60, 90 triangle, hypotenuse is 2x. Opposite the 30 is x. Opposite the 60 is x squared root of 3. And a 45, 45, 90. Two legs are x. Hypotenuse is x squared root of 2.